So nowadays, we are using many products, especially for our daily lives. So, are we aware with its origin or how is it manufactured or is its impact on the environment after on its usage? So, I am sure that we are aware with the waste pollution, its impact to our health, to the environment, and so on. That's why green chemistry was introduced. So green chemistry is important in several reasons. So that's the concept that we will be discussing in today's session. Paul Anastas. So he is the father of green chemistry. He is an American scientist, inventor, author, entrepreneur, professor, and public servant. He is the director of Yale University's Center for Green Chemistry and Green Engineering. Previously, he served as the science advisor to the United States Environmental Protection and Agency. So, green chemistry purposely reduced waste, waste materials, hazards, risks, energy, and the costs. Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. So green chemistry is such a design which is eco-friendly in both the product itself and as well as the process of its manufacture as well its recycling. So the way it was manufactured, it has no significant impact on the destruction or pollution towards our environment as well as the end users, which is us. So green chemistry looks at pollution prevention on the molecular scale and is an extremely important area of chemistry because of its implication towards the environment. Green chemistry applies across the life cycle of a chemical product, including its design, the manufacture, use, and ultimate disposal. So, its ultimate goal is that its design or the redesign of the products and the manufacturing processes is to reduce their impact on the human health as well as the environment. So it emphasizes the concept of sustainability. Sustainability which reduces the environmental impacts and conserving the natural resources for the future use. Though the concept is also applied to before aside from green chemistry, but here this concept of sustainability and conservation is greatly intensified, and we could see that its output is much more positive than the others. So there are several principles of green chemistry. First principle is prevention. So it is better to prevent waste formation than to treat it after it is formed. So in green chemistry, it is an approach that minimizes the hazard portion of the chemical equation. So it is a reduction by using innocuous chemicals and processes. And green chemistry has been successful in devising ways to reduce this pollution through synthetic efficiency, catalysis, and improvements in the solvent technology. First principle is prevention. So it is better to prevent waste formation than to treat it after it is formed. So in green chemistry, it is an approach that minimizes the hazard portion of the chemical equation. So it is a reduction by using innocuous chemicals and processes. And green chemistry has been successful in devising ways to reduce this pollution through synthetic efficiency, catalysis, and improvements in the solvent technology. Third principle, less hazard. Synthetic methods should, where practicable, use or generate materials of low human toxicity and environmental impact. So, green chemistry reduces the pollution at its source by minimizing or eliminating the hazards of chemical feedstocks, reagents, solvents, and products. So it is totally an approach that eliminates the hazards of the chemicals. So it is done by designing better manufacturing processes for the chemical products. Polycarbonate synthesis using phosgene. So what is polycarbonate? So the polycarbonates are a group of thermoplastic polymers containing carbonate groups in their chemical structures. Meanwhile, phosgene is an organic chemical compound. So it is a valued industrial building block, especially used for the production of polycarbonate plastics. But there are disadvantages when using phosgene as a ingredient in producing or synthesizing polycarbonates. First, it is highly toxic and corrosive. So when it was inhaled, 'di ba? Acute inhalation lang, it could cause severe respiratory effects, including pulmonary edema, pulmonary emphysema, and death. Next, it requires large amount of dichloromethane. So this dichloromethane is hazardous to human health as well. So due to this, the polycarbonate gets contaminated with chlorine impurities. There is another method when synthesizing polycarbonate. It is through the solid state process. So the solid state process is a process of welding in which no external heat is applied and the joining of workpiece takes place in the solid state. So polymers in the solid state are saturated with gas under high pressure. So there are advantages when using this method. First, diphenyl carbonate synthesized with phosgene. So diphenyl carbonate is an organic compound. It is a colorless solid. And it is a both monomer in combination with bisphenol A in the production of polycarbonate polymers, and a product of the decomposition of polycarbonates. This diphenyl carbonate is considered as a substitution for phosgene to synthesize polycarbonate resins. So with the use of diphenyl carbonate, it eliminates the usage of dichloromethane, which synthesizes a higher quality of polycarbonates without chlorine impurities. Safer chemicals. Chemical product designed should preserve efficacy whilst reducing toxicity. So, green chemistry is actually an approach or a way to design chemicals and processes so that they are safer, healthier, and more sustainable. So, the way it is manufactured, the way it is processed, are preventing pollution at its source. By creating these chemicals, these processes, less toxic. So with this, it eliminates the exposure of toxic chemicals towards the workers, the consumers, and the environment. Next principle is safer solvents. So avoid auxiliary materials, solvents, extractants, if possible, or otherwise make them innocuous. So it involves the use of a safer solvent and minimizing the total amount of solvents and auxiliary substances used for any given step of the reaction. This is because the solvents and auxiliary substances make up a large percentage of the total waste created. So in most cases, there are no reaction without solvents and separation agents. So this provides for mass and energy transfer. So safer solvents will help to reduce energy requirements, be the least toxic, and have the least environmental impacts. In the table, it presents the preferred, usable, and undesirable solvents. So the preferred solvents are water, acetone, ethanol, 2-propanol, 1-propanol, ethyl acetate, isopropyl acetate, methanol, methyl ether ketone, 1-butanol, and t-butanol. In usable solvents, these are cyclohexane, heptane, toluene, methyl cyclohexane, methyl t-butyl ether, isooctane, acetonitrile, 2-methyl-THF, tetrahydrofuran, silenes, and dimethyl sulfoxide. And lastly, in the undesirable solvents are pentane, hexane, diisopropyl ether, diethyl ether, dichloromethane, dichloroethane, chloroform, dimethylformamide, pyridine, dioxane, and benzene. So these are the sample solvents and their preferred uses. Next principle is energy efficiency. Energy requirements should be minimized. Conduct synthesis at ambient temperature and pressure. So many chemical processes are designed to be as efficient as possible. It is very costly if a chemical synthesis is not designed to be efficient, such as requiring for more heat for the reaction requires unnecessary energy. So, if it is possible, a chemical synthesis is designed to use the least amount of energy possible. So, it is also very costly to use more energy than necessary. So, we could see it in other products. For example, the light bulb. So, the light bulbs now are designed to be more energy efficient than the incandescent before. Next is renewable feedstocks. So, raw materials should be renewable. So, this principle refers to raw materials derived from the natural resources. The usage of renewable feedstocks reduces the amount of harmful waste produced from the crude oil refinery and distillation processes. So the products being produced came from the plants, which is a renewable resource. So the recycling process is considerably more environmentally friendly, more eco-friendly. So through the fermentation of glucose in the presence of bacteria and propanoic acid, it gives polyhydroxy alkanotes, or referred as PHA. So according to Raza, Abid, and Banat 2018, PHA are polyesters stored within cells as energy stored materials by various microorganisms. Due to their biocompatibility and biodegradability, PHA have a wide range of applications in various industries such as biomedical sector, including tissue engineering, bioimplant patches, drug delivery, surgery, and wound dressing. So PHA are green plastics and they have positive social environmental impact when compared with the conventional plastics in terms of production and recycling. The PHA are similar to polypropylene but however biodegradable. Smart catalysis. Selectively catalyzed processes are superior to stoichiometric processes. So, catalysis is a process of increasing the rate of chemical reaction by adding a substance known as catalyst. So, this catalyst is a substance that speeds up the reaction without being consumed along the process. So, this catalyst can be used repeatedly, but it is expensive. So, for example, in industry, research into the desulfurization of fuels is taking place to reduce the atmospheric sulfur. So, catalysts are being developed to remove the sulfur from fuels to prevent atmospheric issues later, such as acid rain. Green catalyst has advantages as readily separated, readily regenerated, long service life, very high rates of reaction, robust to poisons, high selectivity, and works under milder conditions. So it is more positive in the social and environmental aspects compared to other catalysts. Degradable design. So chemical products should be designed to be degradable to innocuous products when disposed of and not environmentally persistent. So nowadays, there are many degradable products that we could see in the market. So when we go to the supermarket, we could see bioplastics, which are much more fragile than the older plastics that we are using. We have also the bio cups, right? As well as the spoons made from bamboo, spoons and forks. The plates nowadays are not like the design before. So it is much more eco-friendly. But then, it is still a huge challenge in the green chemistry to produce these products which performs like the older products, but sustains its for being a biodegradable. So next principle is the real-time analysis for pollution prevention. So monitor processes in real time to avoid excursions leading to the formation of hazardous materials. So the processes in the green chemistry should be monitored in real time. So when they are manufacturing, designing, or synthesizing, the scientists are monitoring the whole process so as to um, solve the existing problems or see the reaction in a specific time. It is essential to ensure that the chemical processes are properly functioning. Lastly, hazard and accident prevention. So materials used in a chemical process should be chosen to minimize hazard and risk for chemical accidents such as releases, explosions, and fires. So these are all the principles in green chemistry. So the following will be the applications of green chemistry. So here it presents the application of greener cleaning technology used as antibacterial products for laundry, for water purification, and industrial cleaning. So the following will be the applications of green chemistry. So here it presents the application of greener cleaning technology used as antibacterial products for laundry, for water purification, and industrial cleaning. Next, there is a new process of cleaning clothes. First is through the use of liquid carbon dioxide. It is non-flammable, non-toxic, and a renewable substance, which is indeed a more eco-friendly than what we use in the traditional cleaning of clothes. Next is through the use of vitamin C that neutralizes chlorine. So vitamin C in the form of ascorbic acid and sodium ascorbate quickly neutralize chlorine and are non-toxic. Ascorbic acid may slightly lower the pH of the water, while sodium ascorbate is pH neutral and does not affect the pH of the water. And the last application to be discussed is the industrial cleaning. So, this cleaner, yan, di na po sasabihin yung name, is a water-based industrial cleaner, non-toxic, biodegradable surfactants, replaces traditional organic solvents, and eliminates the hazardous waste sludge production and VOC pollution, which is indeed more positive to environment when used.